We did pentane. We did pentane, yeah.
So
Isomers of pentane.
we were doing structural isomerism, and it is an isomerism that is coming from different structural formulas. It is coming from different structures, but the same molecular formula. Structural isomerism is classified in three ways: chain, where you or change the order of carbon; position, that is the where you attach the carbon, the group; and functional group isomerism. I had started the chain isomerism, which was discussed here. You can look at this screen and you can observe here that this is 2-methyl butane, 2,2-dimethyl propane. So this is an isomerism. This is an isomerism where the compounds are different input numbers. This is actually a branch. Chain isomerism is actually a study. Chain isomerism is related with this idea. Now, straight chain isomers have higher values of boiling point than branched one. Let's make it our first concept for today. Where there are more branches, you will have less boiling point. Straight chain isomers have higher values than branched one. What are branches? Look at the screen. What are branches? This is called a branch. This is called a branch. This is called a branch. Branches are extra lines of carbon in a structure. So I'm putting my first concept that straight chain isomers have higher values of boiling point than branched ones. So you have to copy this screen.
So basically, the straight chain would be like just normal pentane, and then branched ones would be like dimethyl propane.
Okay. Can you speak a bit loud? Actually, I couldn't hear you.
Yeah, I was saying the straight chain would be just like basically the normal pentane, and then the branched ones would be like dimethyl propane, right?
Yes, this is the straight chain. This is the straight chain, this one.
Okay.
This is the straight chain. And this is called the branched. So can you differentiate now between them?
Yes.
Greater the number of branches, lower is the boiling point. Our first concept today. Greater the number of branches, lower is the boiling point.
Could you go back like to the initial slide we were looking at? Hello?
There is only one way in which 2 or 3 carbon atoms can be linked by single bonds to form an open chain. Therefore, there is only one structural isomer for an alkane containing 2 or 3 carbon atoms. This is not the case with 4 carbon atoms, though. They can form a straight chain, as in butane, or a branched chain, as in 2-methylpropane. The two compounds have the same molecular formula, but differ in the way the carbon atoms are linked together by single bonds. This type of structural isomerism is called chain isomerism. With 5 carbon atoms, 3 structures are possible, 1 linear and 2 branched. Therefore, there are 3 chain isomers of the alkane containing 5 carbon atoms: pentane, 2-methylbutane, and 2,2-dimethylpropane. Notice that this compound is not a 4th isomer of pentane, since it is identical with 2-methylbutane. The number of chain isomers rapidly rises with the number of carbon atoms, owing to the increasing number of possible combinations. For example, there are 75 chain isomers of the alkane C10H22, while for the alkane C20H42, the number of isomers is as high as 366,319. There is only one way in which 2 or 3
Now, give a new heading, position isomerism. This is the second isomerism in structural. Give the heading, position isomerism.
So like the previous concept was that the straight chain have a lower boiling point than the other ones, right?
Now look at the difference. The OH group,
Hello, can you hear
is
me?
connected on
Hello?
position 1. Here,
Yeah,
the
okay.
OH
Hello,
group
can you hear
is
me?
connected on position
Okay.
2. The formula will be the same, but one is called butane 1-ol and the second is called butane 2-ol. One is called butane 2-ol and one is called butane 1-ol. So look at the difference. This is called position isomerism. This is not a branch. Why this is not a branch? Branch occurs only when you take carbon. So look at carefully on the screen. Carbon to carbon to carbon. Now, if I attach some carbon here like this, it is called a branch. But if I connect carbons like this and I attach an OH group, this is not a branch. This is not containing carbon. So this is my next concept. What is position isomerism? It is the difference in positions of a group, but it is not a carbon chain. This is called position isomerism. Did you get it, Shahid? The idea of position isomerism?
Yeah, can you hear me?
Shahid, can you hear me?
Can you hear me? Hello? Hello? Can you hear me?
Shahid, can you hear me?
Yes,
I
I can
can't
hear
hear
you.
you somehow. Let me check again if you are speaking, but okay, I think okay. Shahid, can you speak again? I think I can hear you.
Can you hear me now?
No. You can apply on the chat for the time being. That did you understand the title? That what is a position isomerism?
Yeah, I know. I understood the position isomerism, but I was gonna
I
ask.
can't.
Hello, can you hear me?
Shahid, can you speak something again? I can't. I might hear you now.
Yes, can you hear me now? Hello? Hello, can you hear me?
Some hearing problem is coming. Achha, can you hear me? Can you hear me? Please reply on the chat. Can you hear me? Actually, I can't hear you, but can you hear me? Reply on the chat. Please reply on the chat. Can you hear me?
Hello, can you hear me now?
Yes, I can hear you. Can you hear me?
Yes, I can hear you.
Okay.
I was asking about the first slide that you were showing the branch that I didn't get to copy it.
You were not supposed to copy the whole slide. You were supposed to copy
The
only this one, the boiling point one, right? This one. You have to
yeah,
copy this one.
I was copying this one, yeah.
Okay, copy this.
Yeah, copied.
Okay. We started position isomerism. And what is position isomerism? Look at the screen. It is an isomerism which is which is produced due to change of position of an isomer. So after giving the heading, give the heading position isomerism and write under it, this is a type of structural isomerism. This is a type of structural isomerism This is a type of structural isomerism which arises. This is a type of structural isomerism which arises due to change in position, which arises due to change in position
Yeah, okay, copied.
change in position of a functional group.
Okay.
So I hope you were able to hear when I was explaining this concept. Look at the screen. So look at the screen. One is butanol, butane 1-ol, and second is butane 2-ol. So what is the difference, Shahir? What is the difference between these two compounds?
The but1 and all, it it will have the OH on the one, and then but2 and all, it will
Yes.
have the OH on the second.
Very good. And this is called position isomerism. Now write under it, for example, and copy this screen.
Now I was gonna ask if it can be one from any side, right? So like if it's four on the left, it's still
Huh?
considered one. So the
Ah,
OH, if it's connected to the opposite side, is still one, right?
yes, because I will tell you the rules also. I have to do IUPAC with you also. But I was trying to finish organic chapter 4 as soon as possible because definitely is in the line. Look, with number in the way that we always number from the lower side where the OH will get less number. We number the chain in such a way that OH will get a smaller number.
Okay.
Look at the screen. If I number from
Yeah.
here, it will be considered wrong. Why? Because now OH is getting a bigger number.
Yeah.
So you have to start the numbering. You have to start the numbering so that OH gets a smaller number. Now you have to copy this screen, this example.
Yeah. Copied. Yeah. Copied it. Okay.
Now copy this example.
In this, if you change the position of the double bond, it becomes pent 2-ene and or pent 3-ene, right?
Yes, yes, very good. Now you understood that this isomerism, so-called position isomerism, is actually not disturbing the carbon units. It's actually changing the additional member like OH group, like double bond. Now, have you copied it, this one?
Yeah. Copied.
Now, look at this one. This is
Yeah.
called pent-2-ene. Now, this is a structural isomer, structural position isomer. You have to copy this.
Okay.
Let me know once you have copied it.
Yeah, I copied it.
So we have discussed position isomerism.
A molecule of but-1-ene contains one double bond at the first carbon atom. A molecule of but-2-ene has the same molecular formula, but now the double bond starts at the second carbon atom. The two compounds differ in the position of the functional group, a double bond, so they are called positional isomers. Notice that the compound C4H8 has one further isomer, 2-methylpropene, which is in turn a chain isomer of the two linear alkenes. Generally, positional isomerism is possible in all compounds having functional groups, such as haloalkanes or alcohols. For example, there are 4 structural isomers of the aliphatic alcohol with the formula C4H9OH. They form 2 pairs of positional isomers and 2 pairs of chain isomers. A molecule of but-1-ene contains one double bond at the
Functional group isomerism. This is the third type of structural isomerism. You have to copy this screen. Give this heading.
Okay. This functional group isomerism is basically like the one we saw with butanol, no? Is it similar?
Basically, functional group is like functional group is something like you can say a part of a molecule which is always active in a chemical reaction. Functional group isomers have the same molecular formula, but functional group is different. Now remember this concept. That functional group is the identity of an organic molecule. For example, if I write OH, it means in our chemistry that this is an alcohol. If I write CO2H, it means in our chemistry that this is a carboxylic acid. So this
Okay.
is how organic chemistry works. Organic chemistry basically links always, organic chemistry always works on the functional group. Functional group is the identity of an organic molecule. So look at this example, alcohol versus ether. The names are not important for you presently, but you can see the molecular formula is the same, but the functional group is different. One of them is the alcohol, the left side one, and the right side one is an ether. So now you have to give this side heading. Right under it. In this isomerism, compounds have different functional group. In this isomerism, compounds have different functional groups. For example, copy this. Now copy this screen. Let me know once you have copied it. Okay, sorry, Shaheen,
Yeah,
have you
copied.
copied?
Yep,
Good.
copied. Okay.
After copying, can you tell me what did you get from this example? One compound is an alcohol and one compound is an ether. The names are not important, but the molecular formula is the same, C2H6O, but definitely their properties will be different. Look at the second example. Propanol versus propanone. They are two different families. They are two different functional groups, but their molecular formula is the same. This is called functional group isomerism. You have to copy this screen now. Let me know once you have copied.
And done, yeah, you can go, yeah.
Okay. Now, I'm putting an example. Look at the formula. This is like a practice C4H10O. You have to copy this question.
Yep, copied.
Okay, now start making the structure. So you can try some examples like, remember that alcohol is ROH, aldehyde is RCHO, ketone is RCOR, and ether is ROR. These are the names and the functional group. You're not supposed to learn all of them because it is a long way to go with organic. In unit 2 and also in A2, organic will be rolling up. But it's a type of organic stuff that you should improve the basic memory and how it works. So you have to copy this list for memory.
Okay. The R would represent carbon in this case, right?
R means alkyl radical.
That radical would be, for example.
Sorry, R is like CH3, C2H5. Remember, alkyl radical we discussed before also. If you remove one hydrogen, if we remove one hydrogen from from an alkene, it is called alkyl radical.
Yeah, okay. Yeah, copied all of them.
Now, I will share this picture with you later, but you have to remember that this is a concept of making all possible isomers. So you can start making them position, chain, functional group, and you will make all possible isomers which are possible. This is like a trial and error case.
Compare the following compounds. They both have the same molecular formula, but they differ in the functional groups present in the molecule. Hex-1-ene is a linear open-chain molecule with one double bond between carbon atoms, so it belongs to the homologous series of alkenes. Cyclohexane is a cyclic molecule with only single carbon-carbon bonds, so it's a member of the family of cycloalkanes. This type of isomerism is referred to as functional group isomerism. Other examples of functional group isomerism include aldehydes and ketones, which differ in the position of the carbonyl group, situated either on the terminal or the inner carbon atom. Alcohols and ethers are functional group isomers too. Compare the following compounds. They both have the same molecular formula, but they differ in the functional groups present in the molecule. Hex-1-ene is a linear open-chain molecule with one double bond between carbon atoms, so it belongs to the homologous series of alkene.
Although structural isomers have the same molecular formula, they are different compounds with different physical and chemical properties. This difference is particularly apparent in the case of functional group isomers that belong to separate families of organic compounds. The properties of chain isomers are rather similar to one another, although even isomeric hydrocarbons differ in physical properties such as boiling or melting point. Although structural isomers have the same molecular
IUPAC nomenclature, naming molecules by following the rules. This is a method of naming organic and especially organic compounds. This method is introduced because organic compounds are so many that we can't name them individually. So now you have to put a new title, this screen, that copy this heading.
Okay.
You first have to identify the family that your molecule belongs to. Is it an alkane? It is a alkene? It is an alcohol? What it is? So check for functional group. If there are none, then your molecule is simply an alkane. So what is the concept? Whenever you are looking for, you're starting your job of naming, you first have to look for a functional group. Interestingly, if there is no functional group, it means it is an alkane. If there are no functional group, it means it is an alkane. Look at the rule, the three basic parts. The name for any organic molecule consists of three basic parts: the prefix, parent, and suffix. Each part of the name has a purpose. Now, for example, basic part. The basic part, if you start from here, it is the end of the name. For example, in case of alkene, look at these three letters. We combine them and made ane. We can make other also. Basic part, the parent. The parent part of the name tells you how many carbon are there. For example, methane means 1 carbon. Ethane means 2 carbon. Propane means 3 carbon. This is the main chain of the molecule. Parent and suffix. The parent is named based on the number. For example, 1 carbon is meth. So 1 carbon alkene is called methane. 2 carbon will mean ethane. And so we can continue. 3 carbons, propane, and we can write the formula like this. And in this way, we can continue 4 carbon, 5 carbon, and then continue. Look at this. 5 carbon, pentane. I hope you remember it from O level. 6 carbon, hexane. 7 carbon, hept. And in this way, the link goes on. So now, if you see this compound, I have drawn it in skeletal form also. And can you count the number of carbon atoms, Shahir, and tell me what is it? No need to copy anything. Just count the number of carbon atoms.
9 carbon atoms.
So what is 9 carbon atom? 1 carbon means ethane, methane. 2 carbon
This
means, do you remember that 10 carbon
nonane,
list?
right? It should be none.
It is basically a list.
Okay.
So what it will be? Prefixes are the bits and pieces we attach to a chain. A prefix might be a halide attached to, it's an outsider group. Look at this bromine. This is called a prefix. The family called alkyl halide and does not have a suffix. So we mean fluorine, chlorine, bromine, iodine. So we put the name there. Now, when you put them together, you can name it. And step 1, find the main chain. Step 2, number the main chain, identify all prefixes. Step 4, write the full name. Now, these are the steps which you have to learn. You have to copy this list. Now, these are the steps you have to remember and you have to copy these steps.
Yeah, copied all of it.
Now, look at this skeletal structure. A Excel board is very much interested in skeletal structure. Skeletal structures always trouble the people because in this one, they should remember one thing which always give us trouble, that this is a carbon, 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 this is a carbon.
Basically, every
Every
vertex.
vertex,
Yeah.
every vertex is a carbon, but the confusing point is there that carbon needs 4 bonds to be completed. So when you see only carbon, it is not possible that it is alone. It must be having something. When there is nothing marked, it means it contains hydrogen. Look at this screen, which I'm improving now. All the 4 bonds you have to fill. If some bonds are missing, if some bonds are missing, it is actually, look at this now. This is the actual structure, but it is too long to draw. It is too long to draw. So we use a skeletal structure. If you want, you can copy this and now you can name it.
This should be 4 bromoheptane.
I
I think it's
It's
4.
coming 4. Is 4 coming from both sides?
Yeah, it's 4 from both sides, so should be 4 bromoheptane. I think so. Or yeah, heptane. Yeah, heptane. There's no double bond, right?
So 4 bromo.
Heptane.
Good. Now try this.
Yeah, got it.
Now final answer is 3 bromoheptane. Are you getting it?
Yeah.
Alkyl groups, we have mentioned it many times that it's part of an alkene. Now, copy this skeletal structure, only the skeletal. Copy this skeletal structure along with its name. No need to copy anything extra. every vertex is a carbon. Every vertex is a carbon. Every carbon contain hydrogen if no other element is shown. Every vertex is a carbon.
Yeah.
Every vertex is a carbon. And every carbon has hydrogen if no other element is shown.
So like in a question, let's say they would say this vertex means this, etc. like that, but mostly it would be carbon, right?
Look at this structure. Look at this structure and look at its name. Only copy the structure and the name. Other detail is not needed. You can read it. Let me know once you have copied it. Yes, Shane, have you copied it?
Yep, copied now. Done.
Propyl group. It is then isopropyl group. Then it comes butyl group. It goes on like this and it will be a long way. Now this is a ring. I'm not going for ring presently. I have made the basic idea, and we are already have done a bit more than required, because this is a problem with organic chemistry. You need to make some idea in advance. Even though alcohols, carboxylic acids, they are coming later. I'm sharing some examples with you, so you have to look on them. So let's keep it up to here, and we will inshallah continue this in our next class.
Okay.
Allah Hafiz.
Allah Hafiz.